Hello everybody, this is Kiran and today we are going to learn about bugs and defects. So in the STLC, after the test case creation, the major phase which appears is to execute the test cases. Now once you are executing the test cases, there are various bugs which you might come across, and how do you raise them, how do you manage them is something which we are going to discuss in today's session. First of all, what is a bug? What is a defect? Bug or defect is any deviation from the expected flow of the software. That is, if a particular application needs or is expected to behave in a particular manner, and while you're testing it, you come across a scenario which is not exactly as per the expectations, that is called a bug. You have to mark them as a tester to the concerned person or the developer and get them resolved. Once it is resolved, you have to retest it and make sure that the bug has been fixed, and you have to close the bug. If while retesting you see that okay, the bug is still not fixed or it's still open, then in that case you need to reopen the bug. So there is a bug life cycle, which we need to discuss and understand. We will be talking about bug life cycle in our next session, but for now we have to understand defect management process. So any software defect or bug is any deviation from the expected flow of the software. You can call it defect, issues, problems, bug or incidents, and we have to know how to mark them properly. Let's proceed. Now, bug information. For raising any bug or marking any issue, we have to follow a procedure, and we have to fill in those details and assign it to the concerned developer. If we are using any tool, let's say Jira or Azure DevOps, in those tools we have inbuilt form, and there we need to enter the important details and our bug is marked and maintained. But let's say we are not using any tools in our company, then in that case we have to follow Excel sheets, and in that we have to create our own columns with the list of the columns I'll be mentioning now, and then we'll be raising all the issues and maintaining that Excel sheet. But whatever it is, same as in case of the test cases, the columns remain same and we have to understand and know and remember them. So I'll list down all the columns and we will start understanding each one of them, starting from defect ID. So defect ID is a unique identification number which will be assigned to the defect so that we can search it later on and there is no confusion with the other bugs in the system. So it has to be unique. If you're creating it in an Excel sheet, you have to write a unique ID, and if you're maintaining any tool like Jira, Bugzilla, Mantis, TestRail or Microsoft Azure DevOps, in those cases the ID will be auto-generated. Now, defect description, very important. So we'll take an example of a scenario wherein you are following or using a e-commerce platform and you are trying to make the payment using your debit card, and the debit card transaction is failing every time. So there is certainly an issue in the payment page, so you have to mark that as an issue or a bug. So defect description will be a detailed explanation of the issue. So it will be starting with debit card transaction is failing, and on the payment page something like that can be written. Version of the software is important because anybody who's trying to reproduce the issue should be able to should be knowing that where the testing is being done. So writing the version of the software is very, very important, which build you are actually testing, which environment and everything. So version is mentioned in all the builds which come to the QA team for testing. So you have to take that from there and write. moving forward. Steps to reproduce is again important because somebody who wants to reproduce the issue for fixing it or testing it should know how to actually reach to that particular situation, and sometimes it can be very complex, so people cannot just read the description and reproduce the issue. So writing proper steps with 1, 2, 3 steps is important so that anybody who is trying to reproduce is able to do it properly. Date raised is again an automatic column which gets filled if we are using any tool. If we are marking it in the Excel, then we have to mark the proper date raised. Then reference is any document or website or section of the software from where you have taken a reference that yes, this is a bug. So you're saying that payment is fading, so that must be written in the acceptance criteria or maybe in the functional specification documentation. From somewhere you know that yes, debit card payment is allowed in the system. So from wherever you are sure that this is a requirement of the software, you have to write that reference name. So in our case, it can be the BRD, Business Requirement Specification, or the SRS, Software Requirement Specification, or the Functional Specification Design, FSD. So mostly it will be FSD, and it will be circulated amongst the team members. So we'll say that based on the FSD, this gateway is allowed and here it is failing. We can also give references from the websites, or we can attach screenshots also if you want to. So that it is a proof that yes, it is failing. Detected by is the person who is actually marking the issue, so it's automatically your name, or if it's not there, then you have to mention your name. Status is very important. The bug status we will discuss in the next session, wherein we'll discuss bug life cycle. But for now, you have to understand status is the current situation in which the bug is there. Let's say the bug is still it's in open state, then it will be open, and if it has been assigned to the concerned developer, the status will change to assign. If it has come back to the QA team for testing, it is like with QA, or any other terminology or nomenclature we can follow, that doesn't matter, but the logic is clear that it is with the QA team. And then once the QA has tested it, and if he has closed it, then the status will go to close. If the QA is reopening the bug, it will go to open again. So status is very important. We'll come back to status again when we are doing bug life cycle. Fixed by is the name of the person who is actually working on fixing the issue. So it is most probably going to be a developer who is going to fix the issue. Date close is the date where the bug got closed completely, not reopened or any other problems. It should be closed. So the closure date is also mentioned because it's important to have a track or keep a track of how many days are being invested in finishing off one issue. That when was the bug raised and when is the bug being closed is important, because if there is a multiple cycle of bug getting reopened, it's wrong on the part of the development team that they are not fixing the issue. So let's say you raised an issue, it went to the development team fixed it, you retested it, but you saw that okay, it's not yet fixed, so you reopened it. Now again the development team has fixed it and they send it back to the QA team. Now you're retesting it again and you found that this issue is still not fixed. So there's certainly a problem in the communication, a problem in the requirement understanding by the developer or the tester, or a problem in the environment where both of them are testing. Maybe it's fixed for the developer, it's not fixed for the tester. So there can be issue which needs to be understood and communicated well. So the date and tenure is important to be maintained between when it was raised and when it is closed. There are two important terms in any bug, which is called severity and priority. Again, we'll focus more on these two terminologies in our next session, where we will talk about the difference between priority and severity. But for now, trying to make you understand the difference between the two. Severity is related to the complexity of the issue. If this issue is affecting the system in a very complicated manner or very deeply it's affecting, it's a high severity issue. And if that particular bug is not affecting the system much, it is a low severity issue or very trivial issue. Let's say any spelling mistake is not affecting the system much. Priority, on the other hand, is related to how soon the bug needs to be fixed. So if severity is about complexity, priority is about how soon we have to fix it. So these look very similar terms, but they are different, and we have different examples to make you understand that. So we'll come back to that, but for now you have to understand the difference in the definition of the two. Severity is related to the complexity of the issue, and priority is related to the fact that how soon the bug needs to be fixed. So only how much timeline is allotted for it to be fixed, how much soon it has to be fixed, is based on priority. Severity is always about criticality. So this is the bug information report, wherein we have to fill in all these details. If it is an Excel, yes, we have to write all these columns. If it's a tool like Jira or Bugzilla, Mantis, any other tool, all these tools, all these columns are properly mentioned there. So the columns are majorly defect ID, defect description, version of the software we are testing, steps to reproduce that particular issue, date raised, when did the bug got raised, references, let's say there is any screenshots which you are trying to show and mark the issue, or if you are saying that this bug is raised and there is an issue in the system based on the FSD, or based on the business requirement specification, from whenever you are seeing that, or maybe some internet information detected by is the person who raised the issue or who is raising the issue, and or who is the person who actually found the issue. Status is the current status of the bug, if it is closed, then close. So we will learn about status in the next session. Fixed by is the developer's name, date close is the closure date, and priority and severity, these are very important terms again. Moving forward, guys, now how do you manage the defect? So you know, now understood that, okay, what is a defect and what all fields we have to mark to actually raise that defect. But what is a defect management process? Very important term. So a defect management process contains the following phases, starting from the discovery of the defect. So when you're doing testing, let's say you're doing ad hoc testing, you're doing exploratory testing, or probably you're doing regression testing and you found the issue. So now once you have found the issue, the discovery of the bug happened. Then you categorize the issue. We'll learn about categorization, what all categorization is there. Once you have categorized the bug, then you take one category, start working on the resolution of the same. So it's kind of breaking down the work into smaller sections, but yes, it's important. So you start resolving one of the categories. So once it is resolved, you verify, you have to test it again to make sure that the resolution which was given is correct. Then after testing, you close the bug, and then you report the current status of all the bugs which are there in the system. So that's the defect management process, wherein you're actually finding out an issue. You're first categorizing them. When you know the category of the issue, then you go for the resolution of it, that is, you mark it to the concerned developer and the developer fix it. Now after the resolution is there, after the fixes we have got, we'll do a verification, that is, we have to do our testing again, and if the bug is closed, then you close it. If it is not closed, then you have to report and reopen, and then finally there is a phase which is related to reporting, that is, you gave the final report that okay, fine, now these many bugs are open, these many are closed, and these many are not tested. So this is the defect management process, guys. We'll understand each phase in detail. So discovery of the defect. So we have to find out the defects before the production release. So all the defects, major, minor, everything, the aim is to find it before, even before UAT, so that we get everything, whatever is left in the UAT, and then we can go for easy production release. So there should not be any issues which are left before UAT, because UAT is a kind of end user testing which the client is doing, so that we can have a defect free production release. So you have to make sure that the discovery happens way before the final release to the customers. Now you have to report the defects. So all the defects which you got has to be reported to the development team. So they should know that okay, these many defects have come, and we know our responsibility, who is doing what. There's defect, discovery and reporting of the defect, and finally accepting the defect. So accept defect, your defect needs to be accepted by the developer to whom they are assigned, because there are reasons due to which the defects are rejected. We will be learning those 4 reasons in our bug life cycle. Here you have to understand that the defect must be accepted by the developers, only then they will be actually resolving the defects. Moving forward to the next phase of defect management process, categorization of defects. So let's see in which all categories the defects are segregated into. Here we go. Critical, high, medium, low. So the defects has to be categorized into the severity and the priority, as I mentioned. We will again discuss that, as I said, but this can be critical, high, medium, low, or the nomenclature can vary from project to project. It can be showstopper, high defect, medium defect, trivial defect, or the nomenclatures can be, if it's priority, then P1, P2, P3, P4. So the names can differ, but the meaning remains same, that they have to be segregated well into different categories. It can be 3, it can be 4, it doesn't matter. It has to be decided by the team, the managers. How do you want to segregate, how many distinguished phases you want to have. So the categorization will be based on the severity and the priority. So that is done. So anything which is very critical, is affecting the project directly and is a blocker. So imagine you are not able to make the payment. So there is a big loss in the business if a person is not able to make the payment. So it will fall into the category of high or critical defects. Then there is high defect, which is actually affecting the system, but not a blocker. It is highly affecting the system, but at least product's main feature, but not blocking any business flow. So that will fall into the category of high critical defects. Then there is medium, which is having a minimum effect on the system, and then low is cosmetic issues like small spelling mistakes, or maybe there is a UI distortion. So things like that can fall into the low category. So resolution is the next phase of the defect management cycle. What happens in the resolution? First, it's assigned to the concerned developer. If you have raised the defect, you must be knowing that the section for which you are raising the defect, so if it's the payment section, in the development team who is working on the payment module. If at all you are not aware, you will be raising or marking the defect to the manager, and this manager will assign it to the concerned developer. So assignment of the defect to the concerned person, then scheduling the fixes. So this person will mark that, okay, this defect will be closed by so and so date. So schedule is important. Then fixing of the defects, that is he has fixed the defect and sent it back to you, and report the resolution. That means he will report that, okay, fine, these defects have been fixed, now you can retest it. So the resolution will be done, and then later on, here are the explanation of all the steps which we just saw. Verification. So as tester, you need to verify and check that whether the fixes has been incorporated or not, whether actually the bug got resolved or fixed or not. If you feel that yes, it is fixed, then you'll be closing the issue. And if so, the closure is the next step wherein you're actually closing the issue if you're not finding anything still problematic. So you'll be closing it, and if you feel that no, it's still open, then you'll have to reopen it to the developer. Then you have to report the current status of all the issues. So let's say you have resolved and retested the bugs and everything got closed, then the report will be okay, all the bugs are closed. But some of the bugs got reopened, and the status will contain that how many bugs are still in the open status, how many got closed, and if the report contains that some of the bugs cannot be tested because of environmental issue or any of the fixes, then those can also be mentioned. So the report can contain whatever is the current status of testing, and based on that, those reports have to be submitted to the stakeholders and your managers so that they are aware of the current situation of the testing. So this is all about the defect management cycle. So today we talked about what a bug is, what a deviation in the software flow is. I'll go back to the PPT. Then we talked about the defect management processes, wherein we talked how we discover a bug when we find an issue, what happened. Then we have to categorize into different severities and priorities, and then we actually send it for the resolution. So discovery of the defect, reporting that defect to the concerned developer. The developer needs to accept it. Then you have to also mark that it is critical, high, medium, low, and then the person will be assigned, of course, and then he will be scheduling a fix. So he will be marking that, okay, fine, I'll be able to do the fix by so and so date. He will fix the defect and he will mark that, okay, these had been fixed, now you can retest it. So you will be retesting it, and after retesting you'll be closing it, and then you will be reporting it. So that's about the defect management cycle, and we'll learn more about the bug life cycle and severity and priority in the upcoming sessions. So thank you for now.